Today we're going to be looking at test remediation. This is topic 2, part 2, linear functions, and I will be showing you how to work out every test problem that we just tested over. So this is linear functions. Now, when we look at this one, the slide 3, we're looking at evaluating given equations for correctness. So you have Adley and Emerson and Marisol who were asked to find an explicit formula for the sequence 29, 31, 33, 35. The first thing you're going to need to do is find the common difference. So in your calculator, put in 35 minus 33 and get 2. 33 minus 31 and get 2. 31 minus 29 and get 2. And you see the common difference is 2. The first term is 29. Now Adley said the formula is this. You have 29 plus n minus 1 and the common difference is 2. So when we look at this right here, this is set up correctly according to the explicit formula up here. Emerson said no, that the common difference is a negative 2, and he is wrong, so it is not correct. Emerson is wrong. He's put the wrong common difference right here. Marisol mixed up the first term and the last term. The first term should come first and the common difference should come last. And so Marisol is wrong, and here's why. Adley is correct. The first term is 29, the common difference is 2. The first term is not 2, and the common difference is not a negative 2 or 29. And here's the explicit formula. So Emerson switched places for the first term and second common difference, and Emerson wrote the wrong common difference. Now slide number 4, you're going to go from explicit formula to linear function. So when we look at this right here, we have to come up and find which function right here, function form, will give you a negative 157. So when I write this, this is just like saying right here, you have, if I can get this to right, you have 12 and a negative 157. This is written as an ordered pair. So when I look at this right here, this is my x and this is my y. So this is the same thing as when I'm looking at this. This is my x and this is my y. Now I'm going to substitute the 12 in place of the x all the way down right here, and I've already put it in here for you. Put all of this right here at one time of the calculator and see which one gives you a answer of 157, and you see the third one does. So none of these others will give you the answer of negative 157. Now looking at slide number 5. On slide number 5, which of the following sequences can be described as an arithmetic sequence? So when I look at this right here, I'm going to start the back and go backwards. And I've already worked these out for you. Negative 42 minus negative 33 gives you an answer of negative 9. And we're going backwards. Negative 33 minus negative 29 gives you a common difference of negative 9. And you go through all the way through here, because sometimes some of these sequences, they like to trick you up, and they'll put an odd number ever so often in here, and it will give you a different common difference. So the first one, though, you see is the same common difference of a negative 9 all the way through. And then on this right here, this third one will give you the same common difference. So these are your two answers that you have right here. Now, when you're working these, and as you can see on this one and these other 3, when I start going backwards and find the common difference, negative 32 minus a negative 16 will give me a negative 16. Negative 16 minus a negative 8 minus 8 will give me a negative 24. As soon as you see that these are different, stop. You do not have to go any further. These are not linear functions. Linear functions are only when you have the same common difference. Start the back and subtract going backwards. Now slide number 6. You're going to find the common difference. The first term is a negative 3. You're going to go out 10 places, because I look at this right here, it says 10 places. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put this number right here in the 10th space. The common difference is a negative 3. Now I'm going to subtract the last term of 69 minus the first term and come up with 72. Then I'm going to count how many spaces does it take to get from the first term to the last term, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces from the first term to the last term. And once you find that number right here, which is 9, you're going to take whatever answer you get right here, 72, divide it by 9, and that will give you 8. So the common difference is 8. Now, look at slide number 7 right here. Evaluating given equations for correctness. Now, Adley and Heidi were asked to find an explicit formula for this sequence. Start the back and subtract to find the common difference. -8 minus 0 is a -8. 0 minus 8 is a -8. 8 minus 16 is a -8. The first term is 16. So Adley set this up in the explicit formula, which is right here. And Heidi said, well, this is what she got. So we're going to work this out, and we're going to use the A sub 1, which is the first term is 16, and D, the common difference is a -8. Set it up right here, and we're going to use DSR, distribute, which we just did right here to come up with this one. Distribute, simplify, which we just did, and then replace. Well, we're just going to simplify right here. So now I have the first term, second term, third term. I'm going to write the first term down, -8 sub n, and I'm going to add the 16 plus 8 together and come up with 24. Now, Heidi said, well, hers is correct. So you have a -8n plus 24. This is the same thing as Heidi's. And then look at Adley. She set it up correctly. So both girls are correct. Their problems are just in different stages of working it out. Adley set up the problem using the explicit formula. Heidi simplified her problem after setting up the explicit formula. So both girls are correct. Now slide number 8. Distribute, simplify, replace. Going from explicit to linear function. You're given this explicit formula right here. Now you're going to work this out, and we're going to distribute, which we just did. And then you're going to simplify. So you're going to write down the -6n. Now take and add -13 plus the 6. So take it, add the first term to the last term, and you will come up with a -7. Just bring down your middle term right here, which is a -6n. Now replace. The A sub n is f of n. Make sure that whatever variable you use here, it's the same as right here. So if you put f of x, it must be x right here. Now, this is your correct answer right here. Positive times a negative will give you a negative right here. So this is the same thing as saying -6x minus 7. Number 9, slide number 9, you're going to find the term number given a value. So you have in arithmetic sequence, the first term is 21, the common difference is 8, and you're going to find the 19th term. So you're going to use this explicit formula right here. Substitute in the first term, substitute in the term you're trying to find, which as you can see is right here, and I've color coded it, and then 8 right here. Now, when I put all of this right here at one time into the calculator, I'll come up with the answer 165. If I were to write this as an ordered pair, right here, since we're looking for the 19th term, it would be written like this, 19 and 165. The 19th term of this arithmetic sequence is 165. You're going to find a correct formula right here. Darby has agreed to donate $177 to Spring Hill High School for its library. In addition, she will donate $1 for every book a student or child that visits the library reads during the summer. The sequence shown represents the possible outcomes that Darby will be donated for the summer. And as you can see, here's the formula, right? Or here's the sequence. The first term is 177. She is donating $1 for every book someone reads. So this is your common difference. Which representation models this problem situation? Select all that apply. The first thing you need to do is set up the explicit formula. Then DSR, distribute, which you would just did right here, simplify, and then you're going to replace. So when I look at this right here and simplify it, and when I use distributive property, I'm going to come up with this right here, 177 plus 1n minus 1. Write your second term down first, and then add your first and your last terms together, and come up with 176. Now when I replace it, this is what it's going to look like. The a sub n is being replaced with f of n and f of x. You do not have to write the 1 right here in front of the n or the x. It is understood to be there. Now when I look at this over here, I see that this is set up wrong. This first one is automatically out. It has a common difference of a -1. Our common difference is 1, not -1. Then when I look at this right here, I see that this is a minus 1n. Well, we know this is a positive, so it cannot be a negative. And then when I look over here, this is a 176. They said it's 177. That's wrong. This one is set up correctly, and this one is right here. Now, this is also set up correctly, and you will find it right here. It doesn't matter if you put 176 first and then the 1x, or put x first and then the 176. It is the same thing. It's community property of addition. It's like 1 plus 3 is the same thing as saying 3 plus 1. And then when I look at this, this is wrong. It does not, you're going to subtract 1 from 177 and come up with the 176. Slide number 11. When you're looking at this, you're evaluating arithmetic information given a graph. So the first thing we want to do, you can write this as in a table right here, which I've done, or you can just look at this right here. You see the first term is a -5. So the first thing we're going to do, since all of these are written in explicit form, I'm going to go through here and check the first term. That's a positive 5, automatically out. We're looking for a -5. 9, out. -14, out. -9, out. So the only one with a -5 right here is this one. That's your only choice. Number 14, identify recursive formulas. Which represents the recursive formula for this right here? You see the common difference is a -6. So the first thing I'm going to do is go down through here. If the common and here's the formula for the recursive formula. A sub n equals a sub n minus 1 plus d. Now, when I'm looking at this right here, this has to be a -6 for the common difference. This is 15 out, 15 out. -6, -6. These are two of your choices. Now, since these are the only two left, I'm going to look at these sub numbers right here. I see 9, 10, 10, 9. The order that these are written in are crucial. They're very, very important. You must count backwards consecutive numbers. So when I look at this right here, I should get 10 and then 9, and here's why. If you look at this formula, this has n minus 1. So remember the n right here matches the n right here. If this is 10, then we put 10 right here. 10 minus 1 will give you 9. So the bigger number must be here on the left-hand side, smaller number right here. Count backwards consecutive numbers like 3, 2, 6, 5, 7, 6, 10, 9. These must be counted backwards in consecutive order. Now, if this were by some chance be a n, the letter n right here, and then you have a 9, that would be automatically wrong because you don't know what that n would be. And you can't say it's going to be consecutive. But these have to be consecutive numbers and count backwards, 10, 9. Now slide number 13, which of the following is accurate representation? So you see the first term is 15, the common difference is a -7. So when I look at this right here, if I were to substitute a 15 in place of, if I were to put a 1 right here, the common difference, I should get a 15. Now I can take this and I can put it in my graphing calculator. And I can quickly look at this and see, and I'm going to type in the 15 plus n, which is, you're going to use x, minus 1, parentheses, -7. And then I'm going to go to second and graph. I'm going to match up these right here. My first term is 15. So I'm going to take this right here and I'm going to check, and I'm going to go to 1. The first term is 15. Second term is 8. Third term, yes, it's 1. Fourth term is a -6, and fifth term is a -13. That matches, so that is a choice. Now, this is one of your answers. Now I'm going to look at this B. I see that my common difference is a -7. Yes, common difference is -7. These are consecutive numbers and you're counting backwards, 6, 5. So that is also an answer. Now, when I look at these right here, I see that these ordered pairs have to match these ordered pairs. So I see 1, 15, 2, 8, 3, 1, 4, -6. That matches. So that is your answer choice also. Now this one says that 15 is 8. So I'm going to go down here to 15. And I see 15 is a -83. So as soon as I see one of these is wrong, it will automatically be wrong. So this is not an answer choice. So D right here is not an answer choice. These are your only answer choices. Now slide number 14. You've got a music subscription cost, which is $25 for the first month. So that's your first term right here. And $7 for each additional month. That is your common difference. Jenna thought this was a good idea and decided to pay for it. Which of the representations below model how much Jenna will be paying? Select all that apply. So the first thing I'm going to do is write out my explicit formula, substitute in the 25 for the first term, the 7 for the D, which I have already done for you right here. Now I'm going to distribute. Whether the common difference is in the back or in the front, you still distribute. It's the same thing. Now, when I multiply out, I get this right here. So I'm going to, here's my first term right here, second term, third term. We're going to write the first term down, and then I'm going to add my first and my third terms together right here and come up with 18. So we distribute, simplify, now we're going to replace. So we're going to take the a sub n and replace it with f of n and make sure that this matches. Or I could take the a sub n and put f of x and make sure this is x matches this. Now I'm going to look at all of these over here, see which one matches, and as you can see, these three that you have right here match. It doesn't matter if you put the 18 first, and if you put 18 plus 7x or 7x plus 18, it means the same thing. So these are your only three choices right here. Now number 15. So when I look at number 15, I see that right here, we have to compare functions and tables. So the first thing that I'm going to do when I see f of x equals, I see that my slope right here is a -11. My y-intercept is a -8 right here. Now I'm going to, g of x, this is f of x, this is g of x right here. So the first thing I'm going to do is come up and find my slope. I'm going to count, go backwards. 2 minus a -2 gives you 4. -2 minus a -6 gives you 4. -6 minus -10 gives you 4. Same thing over here. 3 minus 1 gives you 2. 1 minus -1 gives you 2. -1 minus 2 gives you -3. Now I'm going to go backwards again, and I'm going to divide. I'm going to say 4 divided by 2 will give me 2. 4 divided by 2 will give me 2. 4 divided by 2 will give me 2. So the slope is 2, and then I'm going to check. Do I have a 0 written right here? Nope. If I had a 0 right there, I can look over here across from it and see, oh, that's my y-intercept, and immediately not have to do all this work right here. But since we do not have a 0 right here in the x column, then we're going to have to solve for B. So I'm going to take, it doesn't matter which set of points you use, I'm going to look for the smallest numbers and try to get all positive numbers. Sometimes it's not possible. So I'm going to use 1 and -2, and I've written them down for you. So my slope for this g of x is 2, and my ordered pair that I'm going to use is x and a -1. Now I'm going to write out the slope-intercept form right here, y equals mx plus b. I'm going to circle the y, m, and x. Those are the three that have to be replaced by these numbers right here. So my y is a -2, I put them in -2 there, equals, and then my m comes next, which is 2. I write a 2 here. Then my x is 1, so I put a 1 here. Now I'm going to multiply. 2 times 1 will give me 2. Then I'm going to use, and bring everything else down, I'm going to use the inverse right here. The inverse of a positive number is a negative 2. So I'm going to put a negative 2 on each side of the equals. Put your equal right here. This cancels out. Bring down your b. Negative 2 plus a negative 2 will give you negative 4. If I were to write this right here as an ordered pair, it's going to look like this: 0, negative 4. Because if I had seen 0, negative 4 up here, right here, then I would not have had to do this. But it's not, so it's not written up here, 0, negative 4, so I have to use this right here, slope-intercept form, and work it out in order to come up with it. Now, take your g of x, which is your slope, a 2, and I'm going to rewrite it. Here's your y-intercept, and I put it right here. And then I'm going to put it in slope-intercept form. So I have, here's my slope-intercept form right here. So y equals m, which is 2, x, and the slope-intercept is a negative 4. Now, I'm going to replace this y with, because we're looking at g of x right here. So this is 2x minus 4. Now I'm going to come over here and compare. Once I have everything written out, you see the y-intercept of f of x is a negative 8. So I'll put a negative 8 here. The y-intercept of g of x is a negative 4. Now I'm going to go back and read this. Is negative 8 less than a negative 4? And yes, that's true. Because the closer a negative number is to 0, the bigger it is. Look at this one. We're going to compare the rate of change. So I'm going to look at this right here, and I see a negative 8, and I put a negative 11. So I'll put a negative 11 here. The slope, which is the rate of change and slope are exactly the same thing. The rate of change or the slope of g of x right here is 2. Right here. So, and I need to change that. And I put the wrong thing. So just a second. So this right here and should be is 2. And negative 11 is not bigger than a 2. So this one is false. Negative 11 is not bigger. Negative 11 is greater than 2, and that is wrong. So my slope for g of x is 2. Now, I'm going to come down here and compare these. I'm going to substitute a 1 right here in place of the f of x and a 1 right here in place of the g of x. And I'm going to put all of this right here one time into the calculator, negative 11 parentheses 1 parentheses minus 8, and I will come up with negative 19. And when I substitute 1 right here in place of the g of x, I come up with a negative 2. And I'm going to compare these. So in this order that is to have it, that they're asking, f of 1 is negative 19. Is negative 19 less than a negative 2? Yes, it is smaller than a negative 2. So that is true. Now we're going to substitute in a negative 3. So when I substitute in a negative 3 right here, I see that this came out to equal 25. And this, when we substitute in a negative 3, came out to negative 10. And so 25 is greater than a negative 10, and that is true. Anytime you have a positive number right here, it doesn't matter what the positive number is. All positive numbers will always be bigger than a negative 10. Now, look at slide 16. Which of the following table does not represent a linear function? So just like before, we're going to start at the bottom and go backwards. Negative 6 minus a negative 1 gives you negative 5. Negative 1 minus 4 gives you negative 5. 4 minus 9 gives you negative 5. Over here, 0 minus a negative 1 is 1. Negative 1 minus negative 2 is 1. Negative 2 minus a negative 3 is 1. Now, still going backwards, we're going to divide. Negative 5 divided by 1 is a negative 5. Negative 5 divided by 1 is a negative 5. Negative 5 divided by 1 is a negative 5. So this one has the same slope. Now slope, remember, it's the same thing as finding the common difference. So when I look at this right here, these all have the same slope. These have all been worked out. However, this one right here, C, does not have the same slope. You see the slopes are 1, 2, and 3. So this one is the one that is different. An arithmetic sequence must have the same slope for it to be a linear function. So C is the one that does not represent a linear function. Now 17. On 17, we're going to find the average rate of change. That is the same thing as what you just did right here on slide number 16. It's the exact same thing. All you're doing, though, is just finding the slope, and you're doing it the same way. Negative 9 minus a negative 5 is a negative 4. Negative 5 minus negative 1 is a negative 4. Negative 1 minus 3 is a negative 4. Then subtract. We're over here. 0 minus negative 1 is 1. Negative 1 minus 1 is a negative 2. Negative 2 minus 1 is a negative 3. And then divide. Negative 4 divided by 1 is a negative 4. Negative 4 divided by 1 is a negative 4. Negative 4 divided by 1 is a negative 4. So your slope, which is the average rate of change, is a negative 4. Now, number 18, real-world problem solvent finding slope. So you have a chemistry class that starts an experiment with 4 plants that are each 3.3 centimeters tall. Write it as an ordered pair, and this is what it looks like. They provide all the needs of the plant and track their growth. Plant A was 31.3 centimeters tall after 4 weeks. Write this as an ordered pair. What is the average rate of change, which is talking about slope, in centimeters per day of plant A? Remember, there's 7 days in a week. So I've already written these as ordered pairs. Now, here's your slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Set it up. 31.3 over 4. That's what I have right here. Just write them on top of each other. Start the back and put them on top of each other in the correct order. 3.3 over 0 right here. That goes together. And then put all this at one time with the calculator. Or subtract this, subtract that, and then divide it. And that gives you 7. Now remember, there's 7 days in the week. So you're going to take whatever this is and divide it by 7 because there's 7 days in the week, and that gives you an answer of 1. On this one, you're going to find the correct formula. So Jenna has started skating for exercise. She goes 3 miles for the first week. Her goal is to go 4 miles further than her distance from the previous week. Which explicit formula represents the distance Jenna will go? So the first thing I'm going to do is look at this, set it up in explicit formula right here. And your A sub 1 is 3, your common difference is 4. This is what it looks like. Now, when I look over here and compare this, the first thing I'm going to do is check over here for my explicit, for my common difference. Remember, we have a common difference of 4. So if I see right here, this is common difference is 3, that's automatically wrong. 3, automatically wrong. These are your 2 choices. Now, since this is correct, I'm going to look to the front. Well, it said the first term is 3. Well, that's also correct. Now, look in the middle. How did they write the formula? Remember, the formula is n minus 1. So when I look at this right here, this has a plus. So this one is automatically wrong. Slide 20. Now, on slide 20, you're going to find the slope, just like we've been doing for several slopes slides now. Find the slope. And then look, do we have a 0 right here? Nope. So we do not already have the ordered pair, the slope-intercept, the y-intercept given right here. So we're going to have to take this slope-intercept form and substitute out. I'm going to pick one set of points. I'm going to put 2 and a negative 1 right here. That's the set of points I'm going to use. It does not matter which set of points you use because you will still come out with the same final answer. The thing is, I'm looking for small numbers, so I don't have as big numbers to deal with, and I'm looking for positive numbers, and sometimes it doesn't always happen that way. So I'm going to use 2 and a negative 1. My slope I've already found is negative 3. Substitute out y, m, and x. So my y is a negative 1, my m is 3, my x is 2. Now multiply. Negative 3 times 2 is a negative 6. So I'm going to put plus 6 plus 6. Use the inverse right here. Now add negative 1 plus 6 will give you 5. My y-intercept is 5. And when I write it as the order pair, it looks like this. Now I'm going to take this right here, my slope and my y-intercept, and put it in slope-intercept form right here. And that's what I have. Y equals to a negative 3x plus 5. Now I'm going to replace the y for f of x and write it in function form. And so when I do, it's this and it matches this one. 21, we're going to find slope given the equation. So remember, slope is talking about average rate of change. So when I look at this, remember the y, that m is your slope, y-intercept is your b. Now, I'm going to use distributive property. I'm going to multiply all the way through, and I will get this right here. And then I look at this, okay, well, my slope is 1, and that's what I'm looking for. My 2 over here is my y-intercept, which is 0, 2. And your answer for slope is 1. You do not have to put a 1 right here. It is understood to be a 1, and it's fine if you do put a 1. No problem. Now, number 22. On number 22, we're comparing graphs and tables. So the first thing I'm going to do is look at this and f of x. I've got to come up with my slope right here. So I'm going to use the slope formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then I'm going to come up with 2 sets of points. It doesn't matter which 2 sets of points. We have several sets of points listed for you right here. And when I do set of points that we have, we're going to substitute this in. Now I'm going to go ahead and I'm going to write the slope formula out for you right here. So I have, let me put it over here. My slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is my slope. This is the slope formula. Okay, now substitute in right here using the slope formula right here. This is what I just did. Identify 2 sets of points right here. They gave you 1 set of points, and then I came over here and I said, well, okay, this point is at a negative 2 and 1. When you write this down, make sure that you write down the x first, come down here to the x-axis, and then go over here to the y-axis, and then write it second. I'm going to take this set of points right here, put them directly over top of each other, start the back, and the order that you write it in is crucial. It is very, very important. If you get it out of order, it will be wrong. And then I put 1 over negative 2. So my slope is a negative 2. Now I look at this right here, and I've got to come up with my y-intercept. And when I come up with my y-intercept, I see that this line is crossing the y-axis. This is the y-axis right here at 0, negative 3. So here's my slope and my y-intercept. And when I write it in function form right here, I see I have a negative 2x minus 3. This is the function that I'm going to be using. Now my g of x, I'm going to come down here and I see that my slope, I've already worked it out, my slope is 2. And then since right here, I see that I have a 0 now for the x. So since I have a 0 for the x, I do not have to work it out just like what I did on this other part, this other problem right here, because I have the 0 now. Here, I did not have the 0. Over here, I have the 0 in the x. So I can just write down 0, negative 5. This is my y-intercept. Write it in a function g of x, because this is g of x. My slope is 2x minus 5. Now I'm going to come over here and I'm going to compare. My y-intercept for the f of x is a negative 3. My y-intercept for g of x is a negative 5. So read it. Negative 3 is less than negative 5. That's false. Remember, a negative number, the closer a negative number is to 0, the bigger it is. This one, now let's compare the slope. The slope right here is a negative 2. The slope for this one is a positive 2. This says that a negative 2 is greater than 2. False. A negative number is never, ever greater than a positive number. Then we're going to substitute 2 in the f of x and 2 in the g of x, and I've already done this for you. And when you do, you see you get a negative 7 and negative 1, so let's compare. Negative 7 is less than a negative 1. That is true. The closer to 0 a number is, and the negatives, the bigger it is. Now substitute in 0, and I've already done that for you. So a negative 3 is greater than a negative 5, and that is true. Looking at 24, real world problem solved, finding slope. You have a chemistry class that starts an experiment with 5 plants that are 4.1 centimeters tall. They provide all the needs of the plant and track their growth. Plant A was 18.7 centimeters tall after 2 weeks. What is the slope, which is the average rate of change, in centimeters per day in plant A? So when I look at this right here, I see I'm going to use the slope formula. I've already set up my order pairs right here. And the reason why we put 0 here is because at the beginning of the month, the plant was 4.1 centimeters tall. After 2 weeks, the plant now is 18.7. Now, when I set it up right here, look at the way that I've set it up. I start at the back, put this on top, this on the bottom, directly underneath each other. This in the back goes on top, and this is on the bottom, just like this. I've color-coded it. Put these in, and you come up with 7.3. Now, you're going to divide this by 7 because there's 7 days in the week. And when you divide it, you come up with this. So round off, and this will give you 1. Now, number 24, finding slope and write the function given a graph. So the first thing I'm going to do is come over here, and I see that my slope right here, I have 2 sets of points. I see this is also going downhill. We read a graph from left to right. You must be able to read these graphs correctly. You always read them come in from the left-hand side, and you see that this is going downhill, so it is a negative slope. You must be able to read these correctly, and because if you can't read them then correctly, it will be wrong. This is a negative slope. So I'm going to take these 2 sets of points, and I put them right here, and I'm going to put them directly on top of each other. Start at the back and put this on the top, this on the bottom, directly over top each other. This on the top, this one on the bottom. Now put all of this at one time in the calculator, or going across, subtract it going across, and then divide, and you come up with a negative 9/2, or you will say negative 9 divided by 2 will give you 4.5. Now, I have to find the y-intercept right here. When I look at this right here, I'm going to take the y right here. It's hard to find. The y-intercept is not at 0.20 right here. It's slightly off. So I'm going to use a set of points. And I use the... I use this set of points right here. So when I use that set of points, my y is 7. Oh, excuse me, I'll use this one. My y right here is 7. My m is negative 4.5. And my b, we're going to write it down. So when I multiply negative 4.5 times 3, I come up with a negative 13.5. Now, use the inverse operation of subtraction right here, which is addition. Now we're going to add the 13.5 to each side, and of this cancels out, and so now my b is 20.5. Write this as a linear function, so y equals. Now I could write a negative 9/2 right here, or I could put a negative 4.5. It doesn't matter right here. And then put your x plus your slope y-intercept, and you come up with 20.5. Now, go back, make sure that you know how to work these problems, and then take your test. Again.